Welcome back to part 18 of my DIY autonomous mobile robot building series. Today in part 18, using Fusion 360, we will create the internal structure of the head and mount it so that the head rotates together with the HC-SR04 to the left and to the right. If you're just joining us, be sure to check out parts 1 through 17. The links are in the description and the full playlist is at the end of this video. Okay, carrying on from part 17. If we unhide the head and neck component, the head remains stationary while the HC-SR04 rotates. Let's right-click on the head and neck component and isolate it. I decided to color the inside of the head matte black. So press A for Appearance, select Faces, and apply matte black to each internal surface section inside the head. After selecting Home next to the view cube, I realized that the lower internal face needs to be colored too. So I applied matte black to that portion as well. Actually, I found a few other internal surfaces that might be visible through the eye holes, so I colored them black too. Here the footage has jumped ahead with the HC-SR04 visible. Let's unisolate the head and neck component and isolate the HC-SR04 holder. Let's also unhide the HC-SR04 and the upper plastic bushing. Hide the HC-SR04 holder for now. Here I've opened the data panel and scroll down to a file of a 4-pin female DuPont connector. This file is labeled DS1071. You can download step files for 2.54mm pitch female DuPont connectors from this GrabCAD page. Open the folder labeled DS1071 1 by N. Here is the 1.4 step file that we'll need, and you can download this file here. You can find the link to this GrabCAD page in the video description below. Anyway, right-click on the DuPont connector design in the data panel and select Insert into Current Design. Close the data panel and there we have the DuPont connector. The DuPont connector has defaulted to a metallic color for some reason, so let's right-click on it in the browser and select Break Link. Select the entire DuPont connector and select A for Appearance. Actually, the footage has jumped ahead to where I have already applied a matte black color to the DuPont connector. Taking a closer look at the DuPont connector, we can see that this end is where the wires connect, so let's use the Move Copy tool to rotate the DuPont connector to face the other end. Now let's join the female DuPont connector to the male DuPont connector pins on the HC-SR04. So zoom up to one of the insertion holes of the female DuPont connector, go to Assemble and select Joint. Select the central snap point, which actually corresponds to the central wire portion deep down inside the female DuPont connector. Then turn the design upside down and zoom up to a corresponding pin of the male DuPont connector pins and select the central snap point on the end of this pin, upon which the female DuPont connector glides into place. Let's see whether the relative positions of the male and female DuPont connectors are correct or not. Okay, as you can see, the insertion position is a bit too deep, so let's move the female DuPont connector down a bit. I think 2.8mm seems like an appropriate amount. Hit OK. Label the joint we have just created as female 4-pin DuPont to HC-SR04 and hide the joint. Rotate the design to the top view and scroll down to the HC-SR04 holder in the browser and unhide it. Activate the HC-SR04 holder, select the main base surface and select New Sketch. Zoom up a bit and press P for Project and project the shape of the female DuPont connector by selecting it. Next, select the Offset tool, select the projected rectangular shape, enter an offset of 0.4mm and hit OK. Finish the sketch, press E to extrude. It might be a good idea to hide the female DuPont connector. Select all the sections that define the clearance slot for the DuPont connector. Extrude by negative 0.5mm, the thickness of the base of the HC-SR04 holder, which cuts a slot through the base for the female DuPont connector to fit through. Activate the main design, hide the HC-SR04, select each internal corner edge of of the slot we have just created, select the Fillet tool and create a 0.2mm fillet. Here the footage shows the underside of the HCSR04 holder with the upper plastic bushing also visible. Please ignore the holes in the plastic bushing and also the central hole in the HCSR04 holder, as I will change that arrangement upon the implementation stage. When we unhide the head and neck component, we can see a circular space around the plastic bushing and between the 31mm diameter opening in the neck. So I decided to utilize that area to screw on the head and neck. We'll hide the head and neck component again so that we can see what we're doing. I'm not sure why I did it this way, but I created a new component instead of activating the head and neck component. I labeled the new component head half base. Select the underside of the base of the HCSR04 holder and create a new sketch. Press P to project and project the shape of the base of the HCSR04 holder, including the slot we have just created, and hit return or OK. Select the circle tool and sketch a 20mm diameter circle on the origin. Change the line type to construction on the sketch palette and select the circle tool again. Sketch a 31mm diameter construction circle, which corresponds to the diameter of the hole in the head and neck component. For reference purposes, let's unhide the head and neck component, select the circle tool again, and sketch a circle that is slightly larger than the diameter of the head. We'll need to change the line type back to solid and set the diameter of the circle to 80mm. Now select the line tool, change the line type to construction, and sketch a horizontal construction line from the origin to a point just outside the beak. Change the line type back to solid. From Create, select Slot, and then in the submenu, select Overall Slot. Create a slot starting from the origin, extending to the left end of the 65mm construction line. Then give the slot a width of 40mm. Okay, I decided to split this component into two halves, so I decided to change this horizontal construction line to a solid line. Also, let's draw another horizontal solid line through the right half of the circle. Let's just use the trim tool a little bit, not too much, or the sketch will become unconstrained. Here the footage has skipped ahead, where I have sketched a number of holes that lie on a 25mm diameter construction circle for the head to be attached to the HCSR04 holder. However, I changed the positions of these holes at the implementation stage, so I will skip the details on these measurements. Let's finish the sketch. Swivel the design a little to make it easier to extrude. Go to the head and neck component in the browser and hide it. Select the Extrude tool and select all the portions of the shape we have sketched. Extrude by 0.5mm and activate the main design. In the footage, I unhid the sketch of the head half base component. I changed the 20mm diameter hole to 21mm to allow the plastic bushing to easily fit through this hole. I also changed the diameter of this construction circle to 26mm instead of 25. Also, I realized that there is really no need for this base design that will support the head to extend into the beak area of the head. So let's grab the line tool and sketch a straight line from the front right corner of the projected HCSR04 holder to a point outside of the 80mm diameter circle. Then use the coincident tool to make the end of the line segment coincident with the circle. Do the same from the front left corner of the projected HCSR04 holder. Finish the sketch and hit home. Select the Extrude tool and select all the sections forward of the front of the HCSR04 holder and extrude by 0.5mm to cut these sections off. Unhide the head and neck component. Right-click on the head and neck component in the browser, select Move Copy and check Create Copy in the Move Copy palette. Hit OK and hide the original head and neck component to reveal the copy we have just made. There we can see the copy head and neck 2 at the bottom of the browser. From Modify, select the Combine tool, change the operation to Cut, select the head half base component as the target body body and select the head and neck component as the tool body. Hit OK, and there we can see that the copy of the head and neck has disappeared and the excess portion of the head half base component is neatly cut. To remove this excess portion, open up the bodies folder in the head half base component folder, select the body to which the excess portion belongs, right click and select remove. The footage has now jumped ahead with the HC-SR04 unhidden and also the female DuPont connector, plastic bushing 2, the connector tube and the bottle cap unhidden as well. Right click on plastic bushing 2 and select move copy. Check create copy and let's move the copy of the plastic bushing 3 to the rear side. Select joint from assemble, select the central snap point on the plastic bushing 3 and select the central snap point on the HC-SR04 holder, and there the plastic bushing 3 glides into position. This plastic bushing 3 will be used to help mount and support the head. Here the footage has jumped ahead with everything except for the head and neck component. Create a new component and label it tube head. Right click on the tube head component in the browser and isolate it. Select a new sketch and select the XY plane. Select the circle tool, sketch a circle at the origin and give it a diameter of 12 millimeters. Then select the circle tool again and sketch a 14 millimeter diameter circle. Finish the sketch. Select the extrude tool, select the area defined between the 12 millimeter and the 14 millimeter diameter circles and extrude by 50 millimeters. Let's color the tube by pressing A for appearance and apply a white pigment. Tilt the tube head component to show the lower opening. Select joint from assemble and select the center snap point of the lower opening. Next, unhide plastic bushing 3, navigate to the upper view of plastic bushing 3 and select the central snap point of the top surface of the flange of the bushing, upon which the tube head component glides into place onto the flange. Now right click on the tube head component on the browser and unisolate it. Activate the main design, then scroll up to the joints folder, which will be in the relationships folder in the latest update of Fusion 360, and I renamed the new joint head tube to bushing. Now let's unhide the head and neck component. So the tube is poking through the top of the head. I'll just close the joints folder and unhide the section analysis. Zoom up a bit. Here the footage has gone ahead a bit with plastic bushing 3 hidden. Now from inspect, select measure. Select the underside of the tube head and then the inner surface of the head, and we get a distance of 31.754 millimeters. However, that is the shortest distance, so we'll just treat that measurement as an approximate distance. So let's go back to the timeline and right click on the extrude icon for the tube head and select edit feature. Initially I tried 40 millimeters, but that was a little too tall, so I edited the extrude feature again and tried 36 millimeters. Hit OK, and now let's unhide plastic bushing 3. Let's get the top of the tube head closer to the inner surface of the head, so right click on the extrude icon again, select edit feature and change the extrude distance to 36.8 millimeters. Zoom up to see how close the tube is to the inner surface of the head. Okay, the tube is slightly interfering with the inner surface of the head, so let's make the tube head slightly shorter. I finally settled on 36.75 millimeters. Now let's do a bit more work on the head. Select the combine tool, change the operation setting in the palette to join, select the head and neck component as the target body and the head half base component as the tool body. Hit OK, and now these two components are a single integrally formed component. Now hide the section analysis and hide the head and neck component. Create a new component and label it webbing. Let's right click and isolate this component. Create a new sketch and select the YZ plane. Select the rectangle tool, choose center rectangle on the sketch palette, create a rectangle centered at the origin, give it a height of 40 millimeters and a width of 90 millimeters. Finish the sketch. Select the extrude tool, set direction to symmetric and set measure to hole length so that the distance represents the total extrusion rather than just one side. Select the rectangular profile and extrude by 1 millimeter. Let's unhide plastic bushing 3 and activate
activate the main design. Unhide the tube head component. Select the webbing component in the browser, select the Move Copy tool, and slide the webbing up to a position so that it penetrates at the top end by a certain amount. Right-click on the webbing component and unisolate it, and unhide the head and neck component. Select the copy of the head and neck component in the browser, Head and Neck 2, and from Create, select Boundary Fill. Select Capture Position, change the operation to New Component. Select the head, which is actually the Head and Neck 2 component, and select the little square in the middle as the cell, upon which a new component is created. Let's relabel that to Head Tool. Select the Combine tool, select the webbing component as the target body. The operation is already set to cut, so we'll leave it at that, and select the Head Tool component as the tool body. Hit OK. An extra body has appeared here due to the cutting operation with the Combine tool. Hide Head and Neck 2, then right-click on Body 1 of the webbing component and select Remove to remove the excess material. Select the Combine tool, change the operation to Join, select the webbing, unhide the head and neck component and select it. Hit OK. Unhide the section analysis, and there you can see that the webbing is now an integral part of the head. We can no longer use Head Tool because it has been used as a cutting tool, so we can right-click on Head Tool in the browser and select Remove to safely remove this component. Hide the section analysis again. From Create, select Boundary Fill again, select the head as the tool, select the small square as the cell, and select New Component as the operation. Hit OK and rename the new component Head Tool. Let's hide this Head Tool for now. Hide the webbing component and the entire head and neck disappears due to the previous combine operation. So let's rename that Head and Neck and then unhide it. Head and Neck 2 and the original Head and Neck 1 no longer exist as solid objects, so let's right-click and remove both of these components. Now from Create, select Boundary Fill, select the head, and select the little square in the middle as the cell. Change the operation to New Component in the Boundary Fill palette and hit OK. You can see a new component at the bottom of the browser. Let's rename that Head Tool and hide it for now. Hide the head and neck component and select the Combine tool. Select the tube head component as the target body, unhide the head tool, and select the head tool as the tool body. We also need to change the operation to cut. Hit OK. There we can see a slot formed in the upper part of the tube head component. Unhide the head and neck component, right-click on the head and neck component and isolate it. Here I unhid the HCSR04 holder, projected the various holes that are formed on the former head half base component, now integral with the head, and formed corresponding holes in the HCSR04 holder. I changed the positions of these holes during the implementation stage, so I will fast forward over this section. Hide the HCSR04 holder and unhide the head and neck component. Activate the head and neck component, open up the origin folder in the head and neck folder, select Split Body from Modify. Select the head as the body to split, change to the Splitting Tools selection, and select the YZ plane for the splitting plane. Hit OK. Here we can see that the head and neck component has two bodies, one body for the right side and one body for the left side. I decided to create separate copies of the left and right sides of the head, so let's activate the main design first. From Create, select Boundary Fill, select the left side of the head as the selected tool, and check the little square in the middle as the selected cell. Before hitting OK, make sure that the operation is set to New Component. And there we can see a new component has been created at the end of the browser. Before we carry on, let's remove these unwanted tools by right-clicking on them and selecting Remove. Rename the newly created component Left Head. Let's hide the left head component for now, but we see no change because the original copy is still visible. From Create, select Boundary Fill, select the right side of the head as the selected tool, check the little square as the selected cell, and set the operation to New Component. Hit OK and a new component appears at the bottom of the browser. Hide the original head and neck component, rename the new component Right Head, and unhide the left head. Then unhide the original head and neck component and open up the data panel. I decided to save the original head and neck component as a separate file. So right-click on this component and select Save as Body. Then I saved this body as head and neck. And there's the new head and neck file there, just in case I need a new copy. So now we can remove the original or older head and neck component, leaving us with the left head and the right head. Let's close the data panel, unhide the HCSR04 holder, and hide the left head component. From Assemble, select Joint, and actually we'll need to momentarily hide the HCSR04 holder and select any hole or snap point that will have a corresponding snap point on the HCSR04 holder. Unhide the HCSR04 holder, hide the right head, and select the corresponding snap point on the underside of the HCSR04 holder. Unhide the right head and hit OK. Then do the same with the left head. Here the footage has jumped ahead with all the components unhidden and with both the left head and the right head joined onto the HCSR04 holder. I'll just label the joints right head to HCSR04 holder and left head to HCSR04 holder. We can close the joints folder for now and then open the SG90 folder and open the joints folder inside that folder, which will be inside the relationships folder in the updated version of Fusion 360. Right-click on Revolute and select Animate Joint Relationships. And there we have the head rotating together with the HCSR04 and the HCSR04 holder in accordance with the rotation of the SG90 micro servo. To continue, click here for part 19. If the link isn't showing, part 19 isn't quite ready, but should be soon. Check the description for my uploading schedule. Thank you for watching.